Hello! It's still Friday, which is why I'm in the same shirt, but hopefully you watched the mitosis video, and now you're watching the genetics video, and you are learning and studying for your science test. At least that's my hope. Maybe you're even enjoying the beautiful weather outside and sitting here with your laptop learning about how Gregor Mendel grew plants outside and making those connections. It could happen. So anyway, we're going to be talking about genetics, specifically about Gregor Mendel's crosses and about Punnett squares, about probability. It's going to be fabulous. So it all started with one man. His name was Mendel. And he had an interesting life. Your My Planet Diary talks about the sensation of having something that was lost and then found again. The reason the My Planet Diary talked about that was because Gregor Mendel wasn't always crazy about peas. He actually started out as a physicist, and he had an amazing teacher that he wanted to study with, an amazing man by the name of Christian Doppler. Christian Doppler is famous for the Doppler effect. You know, like, meow. You know, like, meow, meow. Doppler effect. Like when you're sitting at a red light and you hear an ambulance, but you don't see it, that's the Doppler effect. So Gregor Mendel thought that Christian Doppler was amazing, and he wanted to study with him and wanted to learn from him. But there was one little problem. Christian Doppler had decided to move to an abbey, a place that is very reverent and worshipful, which is great, but not necessarily what Mendel wanted to do, because Mendel wanted to be a physicist. So he followed Christian Doppler to the abbey, and the abbey said, "Oh my gosh, we're so thankful to have you. We're going to put you in the garden." No! Gregor Mendel didn't want to be in the garden. He was a physicist. And so he took it all in stride. And he said, okay, I can make this work. I get to be near Christian Doppler. I get to still do science. I can handle it. But because he was a scientist, he couldn't really give up. He couldn't help but notice the patterns that were in the life surrounding him. So he started studying the pollinators, looking to see which butterflies and bees came to which flowers at which times, and kind of tracking their progress. And what he quickly noticed is that there was a pattern. Depending on which flower a bee went to, the flowers of the seed inside the flower would look different. So he started doing more and more research. The story gets even more interesting, though, with Gregor Mendel. So on our left, we have Christian Doppler, and then Gregor Mendel, and then we have a gentleman by the name of Charles Darwin. Gregor Mendel had decided that he loved his life at the Abbey. He was happy, he felt fulfilled, and so after his death, he wanted all of his research to be burned. It didn't matter to him anymore. Luckily, he had a lab partner that thought differently. He thought, Greg, your work can't go to waste. We gotta stay with it, buddy. You gotta keep it. You gotta publish it. You gotta go somewhere. So, meanwhile, Gregor Mendel passes. His buddy just kind of holds on to it for a little bit. And it's a really good thing he did, because Charles Darwin, this guy, he gets kind of a bad rap sometimes. And partly because he came out with a paper that was totally wrong. It was all about pollinators and patterns of inheritance, and he didn't know what he was talking about. And so Gregor Mendel's buddy came forward, and he's like, hey, Darwin, hey, Charles, I got this paper. And Charles Darwin read it and reviewed it and came out to develop some really, really good stuff about adaptations. Had Gregor Mendel's research not been saved, who knows where we would have been. So we go from Doppler to Mendel to Darwin. What's gonna work? Teamwork. What's gonna work? You know what works. It's teamwork. So, Gregor Mendel was the father of genetics, the father of heredity. Heredity is simply the passing of a physical characteristic from a parent to offspring. Mendel wanted to know why, when he was looking at the flowers, they were either pink or white. Why, when he looked at the peas, they were either yellow or green. Why, when he looked at the peas, they were either tall or short. He wanted to know the reasons behind why things looked the way they did. And he called these observations that he was making traits. Traits. A specific characteristic passed from parent to offspring. a specific characteristic that an organism can pass from parent to offspring. Well, if you look back up at the definition of heredity, heredity is the passing of physical characteristics, and the trait is a specific characteristic. So you can actually manipulate those definitions to make heredity the passing of traits. I love that this chapter's vocabulary is all like interwoven. So, after Mendel started recognizing these traits, he became engrossed in his research, and that is why he is the father of heredity. And I know I said he was the father of genetics, but genetics is simply the study of heredity. There you go. Again, interwoven. So let's talk a little bit about his experiments. When Gregor Mendel was following these patterns of traits, it was really important that he only used purebred pea plants. That's right. He wanted a pea plant that had the same characteristic generation after generation after generation. Purebred is something that has the same characteristic or same form of the trait generation after generation after generation. Whew. Like a bulldog, for example. A bulldog's parents were bulldogs, and their parents were bulldogs. We consider a bulldog purebred. He wanted to do the same thing with his pea plants. So he looked at the genes, which is the factor that controls the trait, the chemical makeup inside of what it looks like. And what he discovered is that all genes have one allele or a form of trait from its mother and one allele from the father. So you got one from your mom and one from your dad that made everything that you are. If the trait showed up all the time, anytime it was there, he called it the dominant trait. Kind of like a dominant personality. Somebody who always likes to talk and is like, "Yeah, I'm all here, listen to me." That would be a dominant trait or a dominant person. The recessive allele was a little bit more chill. It's like, I'm just going to hang out. I got it. I'm good. I'm here, but I don't need to show off. And the way he knew the dominant or recessive allele was that he started to look at the pea plants. And what he saw was if he crossed a wrinkled pea plant with a round pea plant, he would get a round pea. And if he crossed a yellow pea plant with a green pea plant, he would get a yellow pea. So forth and so on. The first set of peas he crossed, he called the pea generation. Like pea, as in peas or parents or purebred, because both of the plants he used were generation after generation of the same trait. He then called the second generation the first filial. Filial is a fancy word, and it simply means son or daughter in Latin. So he took a purebred white plant and a purebred purple plant, and what he saw in the first filial generation was a purple plant. Then he took two offspring from the F1 or first filial generation, and he crossed them. And what he saw then was he came up with 4 offspring, 3 of which were purple and 1 of which was white. Where did that white one come from? It came from 2 purple parents. What's going on there? What he realized is that the trait always reappears in that F2 generation. And then he wanted to know why, and he wanted to know how. And it all comes down to probability. Thinking back to those crosses, 3/4 of them had tall stems or purple flowers, and 1/4 had short stems or white flowers. He applied what he knew about probability to the law of genetics, and with some help from a friend, he came up with a tool to help him make predictions in the future. I'm going to stop this video here, and I'm going to do another one about this tool, magic box of science, in a moment. So, if this is all you needed, have a great night. If not, follow me to the next video for Punnett Square practice. Have a great one.